There's a lot of complexity in an R2R digital-to-analog circuit if you try and analyze it in the analog form. If you know binary, pretty easy to deal with. Here we have an R2R analog circuit connected. We have an inverting op-amp amplifier, which means we're going to get a minus voltage out of there. And my way of showing how this works, without going through all the math and the analog analysis, is just to take the least significant bit and make that a 1, see what that voltage is going to be. So I'm going to do that by flipping the switch closed. And after I flip the switch closed, I read the meter, and it says it's minus 625 millivolts. So now I know what a bit is worth. So I'm going to turn that back off once again, and I'm going to select the next most significant bit. I'm going to close that, and I'm going to come back down to my meter, and I read a value of minus 1.25 volts, which is twice what the least significant bit was, and that's exactly what binary tells us. Just to make sure that this continues to pan out, let me close this switch, and I'm going to go up another significant digit and do that, and we can see the meter value tells us minus 2.5 volts, and I can continue to do this for the most significant bit, and that's minus 5 volts. And also too, if I have a combination of the two, so I have these two switches closed at the time, and that 5 volts plus the 1.25 volts weight add up to minus 6.25 volts. And rather than going through all the analog network math to figure things out, you can just do it using binary, and this works very well for a technician.